This is the continuation of Rust workspace inheritance in cargo.toml video. Here in this session we will learn some cargo commands like cargo tree and cargo tree with invert, cargo run with timings, cargo add, cargo remove. Here rand crate is used by three crates such as main workspace crate and bin crate and lib1 crate. We can see the tree-like structure for all dependencies and its sub-dependencies using the command cargo tree. Let's see it. See here, bin1 uses lib1 and lib2, then rand JSON crates, and lib1 uses rand crate, and rand uses rand chacha and rand core, like the tree structure is going on. This tree shows the forward direction, that is crate and its dependencies, then dependencies of dependencies, and so on. If we want to know which are the crates used rand crate, we can know that by using the command cargo tree -- invert rand. This is the inverted tree, that is rand crate is used by bin1 and lib1, and lib1 is used by bin1 and lib2, and so on. You can learn more about this from Cargo Book's Cargo Tree command section. In the next few minutes, we will learn about cargo add and cargo remove. In Rust Workspace Inheritance project, we used 3 external crates and we have 3 internal crates. This is our small structure. In the real-time project, which uses many external crates and many internal crates and gRPCs, microservices, actors like Redis, JWT, mailers, SSOs, GraphQL, Actix, and many more. In a big project, there is an useful analysis, that is, we need to know how much time it takes to compile each crate. For that, we have timings option in cargo run command. Now I am running bin1 crate with timings option. The timing analysis is stored in HTML format under cargo timings folder. Let us open this timing HTML file. Before that, see that build folder. It has all compiled crates and its compiled dependencies. See, here are the build timings information. Let me increase the scale factor to make it big. See, the total timing to build is 8.2 seconds for this small project. Being a small project and it's a debug build, the release build takes some more timing, which is caused by its full optimization. And see, here it shows all crates and its dependencies from in-depth. So the first level is pragma grow, and then Unicode, then SERDI derive, SERDI JSON. Then the next level is get random, and then the next level is rand core, and so on. And the bottom level build is our lib2 crate, then bin1 crate. Here the build hierarchy and build timings are shown, and also the timing taken for each crate to build. As in the crates release track, sometimes there is some issues may happen. In that time we need to remove some specific crates and once again we need to rebuild it. For that we don't want to clean entire builds. Instead of that we can clean the specific crate using the command cargo clean -p crate name. We can also clean multiple crates in the single command by repeating -p and its crate name. Here I cleaned only SERDI crate and see the build folder. Only SERDI crate is removed. And once again let us remove SERDI JSON and SERDI derive. See, it's removed in build folder. Once again let us run with timings. Now see here, the removed crates are only recompiled and added to make the new binary. Now see the timing. It takes only 5.9 seconds. And the next is cargo add and remove commands. Here I open sample project which uses SERDI and SERDI JSON. First I remove the crate SERDI from dependencies. See the ID once again do the indexing and fetch the metadata. You can see more about this from cargo book. Okay, now let us add SERDI with its feature derive. By the command cargo add, we added. See the verbose in console. Thank you.